String theory is a mathematical framework that attempts to reconcile two seemingly incompatible theories in physics, that is, quantum mechanics and general relativity. It's, in other words, an example of a theory of everything. It proposes that at the most fundamental level, the universe is made up of tiny one-dimensional strings rather than point-like particles, and every mode of vibration of these strings corresponds to a different particle in the universe. String theory is a highly mathematical theory and its equations are very complex. The mathematics of string theory involves a combination of quantum mechanics, general relativity, and advanced mathematical concepts such as topology, algebraic structure, and group theory. These mathematical tools are used to describe the vibration of these strings and the way they interact with each other. Depending on the allowed vibrations and interactions of these strings with each other, several versions of string theory can exist, such as type 1, type 2a, type 2b, and so on. One of the most promising and widely studied variants of string theory is known as M theory, which is thought to be some sort of the unification of all these versions of string theory that exist. M theory postulates the existence of 11 dimensions of space and time, and its equations are more complex than those of traditional string theories. As for the significance of the N in M theory, its exact meaning is not known, but it is speculated to signify membrane or matrix. String theory as a whole is a highly debated topic in the physics community, and its viability as a physical theory is still an open question. There are both pros and cons to the theory, and physicists are still exploring its potential implications for our understanding of the universe. Let's look at some of the pros of this theory. The first is that it attempts to unify quantum mechanics and general relativity, which currently are described by separate theories, and if this is successful, it will be a major achievement of physics. Secondly, string theory predicts the existence of new particles, though that have not yet been observed experimentally, such as supersymmetric particles. And if these particles are discovered, it will really be a major breakthrough in physics. And lastly, string theory tries to provide an explanation for the existence of dark matter, which is currently one of the biggest mysteries of cosmology and astrophysics. As for the cons, the most common one is the fact that there is a lack of experimental evidence to verify the theory. The strings predicted by string theory are perhaps too small to be observed directly, and there is really no experiment that can be carried out to verify the theory, to test the strings actually. Also, string theory is a highly complex mathematical framework that requires a deep understanding of highly advanced mathematical concepts, and it makes it kind of intractable for physicists to really evaluate the theory. Some of the key figures who contributed to the development of this theory include Edward Witten, who is a physicist that contributed to the development and popularization of string theory in the 80s, and he is also the only physicist to have won a Fields Medal to this date. We also have Michael Green and John Schwarz, who in 1984 discovered that string theory can naturally include gravity and still be consistent. We have Andrew Streminger, who is known for his works on black holes and their relation with string theory. We also have Johan Maldacena, who is known for his works which attempted to relate string theory in a curved space-time to a quantum field theory on the boundaries. We can also point out Joseph Polchinski,
who made significant contributions to the interactions of strings, including the discovery of D-branes, which are important objects in string theory. Also, we have Michio Kaku, who is a theoretical physicist and author of many books. His contributions to string theory and his applications to cosmology and the study of black holes are numerous. And lastly, we have Brian Greene, who discovered mirror symmetry in string theory and helped popularize the theory through his books and productions. There are other ones. The list is non-exhaustive. I can't list all of them here, but these are some of the main figures. So as you can realize, string theory is really not an easy theory to deal with so many great minds that have been working on it perhaps for decades, actually. To conclude, we can say that despite the fact that string theory could have a lot of promising features, it remains a highly controversial area of research with a plethora of ongoing debates about its validity as a physical theory. Well, even if you find this theory little promising, mind liking and subscribing, as you surely find the upcoming topics more promising or more interesting. See you.